function in order. So the statement on the top is going to run first and the statement after that until we hit the end of the function. So this is what we mean here. To really drive this home, we can come here in our main function and say std number1 and say std endl. And by the way, this endl statement is going to print a new line. We're going to see it in effect in a moment. Let's actually take it out so that we can see its effect. We're going to also do std cout number2. And what this is going to do is to print number1 and number2 on the terminal. Let's build this program. And if you want to build the default task, you can hit Ctrl-Shift-B for it to happen very fast. But I am always going to come here so that it is really clear what I am doing. Our program should be generated now if we try to run it by typing rooster.exe. And again, we can hit the up arrow button on our keyboard so that the last command that we run from this terminal runs, and this is going to speed things up a little bit. So if we run this program, it should say number1 and number2 as you see here, but these two things are cramped on one line, and the reason is we are not printing new line characters after we print number1 and number2. And we can solve this problem by putting in two less than symbols and saying std : endl. This is going to put a new line character after number1. We can build again for our new changes to take effect. To put a new line character after number1. We can build again for our new changes to take effect. After we do that, we click on the terminal, we hit enter, we hit the up arrow button. If we run, it's going to say number1 and number2 on two separate lines because we are printing a new line character after number1. I really hope this makes sense. Please do take some time to play with us, because if this is the first time you're doing this, some things might not be clear, and the best way to really make sense of this is to type code, run it, and see the effect of what you type by running your program. So let's do this a couple of times. So we're going to do std endl. After the statement for number2, we're going to do std cout number3, and we're going to do std endl. To really show the problem again, we're going to take out std endl on the number2 line. We are going to build. Build is going to be successful. We're going to click in the terminal, hit enter, hit the up arrow button, run the program again, and you're going to see it's saying number1. It's going on the new line, printing number2, but we're not jumping to the new line from number2. So number2 and number3 are going to be cramped on one line. That's what we see here. You can solve this again by putting in a new line after number2. Let's do std endl here, and this should solve the problem. Again, let's build. We're going to run our build task. The build is going to be successful. We're going to hit the up arrow to run the program. If we run it, it's going to say number1, number2, and number3, and this is really good. Now it should be clear that statements in the main function are run in order from top to bottom, and that the program is going to end when it hits the end of this curly brace that englobes our function. We're going to have a chance to learn more about functions in detail later in the course, but we are just getting started and we need to start somewhere. So that's why we're doing this main function thing here. Another thing you can do is return from the main function, and in many examples you will see people do return 0, something like this. And this is a way for the main function to send the message to the operating system if it finished successfully or if there was some kind of problem. We're not going to go into any more details about the main function because that's really too much for now. We are just getting started. We are trying to get a feel of how C++ works. The main message here is really that you should be able to print things to the console using std cout. You should be able to print a new line after your message using std endl. This std cout and std endl thing come from the IOStream library that we are including here. If we don't include this library, we're going to have problems because our C++ program is not going to know where they are coming from. So we should really put this in if we want to use these features. And we can return from a function to let the system know, the operating system, if the program finished up successfully or if there was some kind of problem. And again, this project is using the templates we've done before, and this is really all we set out to do in this lecture, trying to make sense of the main function in C++. To really practice these things, I would challenge you to write a C++ program just like this that is going to print your name 10 times. Try to do that, and if you have a problem, please do ask me and I will do the best I can to help you out. This is really all we set out to do in this lecture. I hope you found it interesting. We're going to stop here in this lecture, and the next one we're going to start and learn about comments in C++. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about comments in C++. Comments are a way to put some messages in your C++ code that are really meant to be read by humans. And one way we have to do comments in C++ is through this / thing we have here. This is going to comment out the line, so the compiler is really not going to care about it. It's going to think that it is something that is meant for the developer to see. So this is a one-line comment, and this is how you do it in C++. You can also comment out a block of code in your C++ code, and this is something that comes in quite handy many times. You put your comment in a / and a * like this. This is going to comment things out in your code, and the compiler is really not going to care about this. Let's hop over to Visual Studio Code and actually play with this. So here we are in the folder that is going to contain our code. The first thing I'm going to do is go through the template project. I'm going to copy my files, and I'm going to go up again, and we're going to be learning about comments. So I'm going to put this in the folder on comments. I am going to close whatever folder we have opened in Visual Studio Code, and I'm going to browse to the location where my project on comments is. My project is in this folder that is named 33 comments. I'm going to open the folder, and if I open the main CPP file, I'm going to find the starter project. We're going to remove this const eval thing because we're really not ready to understand this yet. It was in here to help us test that our compilers support C++ fully. So we're going to remove this, and we're going to put in a message that says hello world. You already know how to do that from the last lecture. So we're going to say stdc out hello world, and we're going to say stdendl, and don't forget this semicolon at the end. If you do, you're going to have problems. So make sure your code looks like this. Try to weld it to make sure it's working fine. This is going to run the GCC task weld. You can click on the terminal here, and it's going to close the terminal, and we can open a new terminal here if we want. If we do dir, we're going to find our rooster program inside. We can run it, and it's going to say hello world. We already know to do this from the last lecture, and in this one we are going to be learning about comments. The first thing you can do is use //, so let's do that. And let's put some message here. This brings in the IOStream library. This is a nice message that is going to give some more information about this statement to whoever might be reading this program. And this is called a one-line comment. You can really put this wherever you want in your C++ file. We can go in the main function, for example, and say this is going to print hello world to the console or the terminal. We can really put this anywhere. We can even put it after the return statement here, and really put in whatever piece of information we think is going to make sense to whoever is going to be reading our program. Okay, this is how you do a one-line comment. You can also do comments across different lines, and the way you do that, you put that in the /* and go down and say */ like this, and whatever is going to be in the middle here is going to be a comment. This is usually called a block comment. You can put in whatever you want. So if you have a piece of text that you would like to use as a comment in your program, this is one way you can do this. One thing you should know though is that you cannot nest these things. But before we do that, let's try to build our program to really show that there is no problem if we have these comments in. The build is successful, and if we click on this terminal and hit enter and hit clear to clear things out in the terminal, we can try to run our rooster program, and it's going to say hello world. You see that all these green lines, which are comments, are really not affecting the program. All the compiler is going to care about is this include thing. It's going to care about the main function here. It's going to ignore these green things. It's going to be like these green lines that are our comments are not in there. This is the effect comments have on your program, and we're going to be using this a lot in this course. One thing you should know though is that you cannot nest these block comments. So if you try to do something like this and say this is one comment, and come again and say this is another comment, you see that we have problems already. Nesting is not allowed. You're going to get a compiler error, and we're going to learn more about these errors in the next lecture. But don't do this. Don't nest these block comments. If you do that, you're going to get some confusing errors, and this is going to be the cause for them. So don't nest your block comments. It's going to give you headaches. Okay, this is really all we set out to do in this lecture, learning about comments in C++. You can do one-line comments on a single line like this. You can do block comments to comment out a block of text. You can't nest your block comments because that's going to give you a lot of problems. You don't want that. And really use comments wisely and don't overdo it because it's going to turn your program into a novel. And I don't think people want that. So use this feature when you need it to give some more information about your code, and don't overdo this. We are going to stop here in this lecture. In the next one, we're going to learn about different kinds of errors and warnings you can see in your C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about errors and warnings in your C++ programs. There are three kinds of errors or warnings you can get. You can get compile time errors, you can get runtime errors, and you can get warnings. But what is really meant by these things? Remember, the ultimate goal of every developer or every C++ developer in our case here is to be able to generate a binary executable file from the C++ code. And we have to run the code through the compiler to be able to do that. And one thing you should know is that there is a set of requirements that the compiler enforces on our code for it to be able to compile successfully. And those requirements are the rules really that we have to follow in our C++ program. And if we break those rules, we're going to get problems, and these problems are going to come in the form of compile time errors, runtime errors, or warnings. Let's look at compile time errors in detail. Here we have a simple C++ program that has a few problems. We have forgotten to put the semicolon at the end of our stdc out statement here, and the compiler is going to freak out because of this. If we compile this program, we're going to get a bunch of errors, and the IDE is going to show us this problem. Some IDEs are going to give you different errors. For example, here I was using CodeLight, and it was saying error expected semicolon before return, or something like this. So this is a compiler error, and if you have this kind of errors, your program is not going to compile, compilation is going to fail, you're going to get this error, and you're not going to get your binary executable. And when you have this, you basically have to go back and fix this problem, compile again, and when you get rid of these problems, the compilation is going to succeed. This is what a compile time error is. Another thing you can have is a runtime error. This is not going to cause a compile time error. The compilation is going to succeed, but when you run the program, it's not going to do what you intended it to do in the first place. For example, you may want it to print green on some user interface, it's going to print gray or whatever. It's really not going to do what you want. So it's a logical error that you have in your program, and you have to fix it to get rid of this. And another thing you should know is that sometimes these runtime errors can cause your program to fail and terminate immediately, and we say that the program has crashed. We're going to see an example of this in a minute. The last kind of problem you can have in your program is a warning. This is a problem that is not serious enough for the compiler to halt your compilation. Compilation is going to succeed, but this is basically the compiler telling you you are doing something that has some problems, and you should really fix it before it becomes a serious problem. So that's going to be a warning. For example, here you see some compilers can warn you when you divide stuff by 0, and we're going to see how this works. The main message in this lecture is that you may have problems in your program, and they are going to come in 3 forms. Some are going to be compile time errors, some are going to be runtime errors, some are going to be warnings. We are going to hop over to Visual Studio Code and actually play with this. Okay, here I am in Visual Studio Code. The first thing I'm going to do is to set up the template project we're going to be using in our project here. The project is going to live in this folder, errors and warnings. I am going to copy over the files, and I am going to go in the current project we're going to be working on, and I am going to open this folder in Visual Studio Code. I am going to go to File, Close Folder. I am going to close this one, and I am going to open our new project. I am going to browse to it. The project is this one. I am going to select it and select folder, and it is going to open up in Visual Studio Code. I am going to close this welcome screen and open our main CPP file. We're going to get rid of this const-eval thing. This is a C++20 test thing we had in. We don't really need it now. We're going to get there in due time. What we want to see is compile time errors. We're going to put in our stdc out statement, hello world, as we usually do. We're going to end this std and we're going to remove the semicolon on purpose. And if we try to compile our program like this, we're going to get a compile time error. This is what we want to see. So let's try and build our program. We're going to run the task to build with GCC, and you see that the build fails. We're going to get a bunch of errors in our terminal. It's going to say in function int main expected a semicolon before return. It's going to try its best to tell you what the problem is, but sometimes these errors can be really confusing. In this case, it is really easy because we introduced this error on purpose, so we're going to fix it in a minute. But before we do that, I want you to see this problems tab. It is where the problems are going to show up in Visual Studio Code, so you should see your problems in here or through the terminal here. Okay, one thing you should know is that when you have a compiler error, compilation is not going to succeed, and you're not going to have your binary file, which is what you really want. So to fix this problem, we're going to put in our semicolon here. We're going to build again. We're going to go to terminal, run task. We're going to build with GCC, and this time you're going to see that compilation is going to succeed, and we have our program here. We can run it through the terminal here, so we're going to click. The terminal is going to go away, but we can open our own, and if we do dir, we're going to see our files in here, and we can run our program. We can say rooster, and if we run, we're going to have hello world. So I hope this really makes it very clear what a compile time error is. So this is one kind of error you can get. The other one is a runtime error. And this comes in the form of things that don't work as you really expected. So let's say we are trying to do some computation in our program. We try to take 7 and divide this by 0, for example. And this is a statement that is allowed in C++. So let's try and build this and see what we get, because this is a common scenario where we have runtime errors. We're going to run the task to build with GCC. Okay, if we do this, you see that build finished with warnings. We didn't get a compile time error, and our build was successful. So to really prove this, I'm going to go back in our directory. I'm going to do dir. You're going to see that rooster is there. I'm going to remove it. I'm going to say rooster.exe. This is how we remove stuff from the command line. When I do this and do dir again, the executable file should be gone. So let's try and build with this statement in, and you're going to see that we get a warning and not a compile time error like we had here. So we're going to go to terminal, run task. We're going to build with GCC, and you're going to see that we're going to have our executable here, but we had a warning, and it's saying that division by 0 was detected in our program, and it is a recipe for disaster. So why is it a disaster? Let's try and run this program. So we're going to dir to prove it's here, and we're going to run it. If we run it, it's going to say hello world, and it's going to end. Let's try and actually use our own terminal to see if we have a better chance of seeing the problem here. So I'm going to reveal in Explorer by clicking on main CPP, and I am going to try and open a terminal window here, PowerShell, that we open ourselves. We've done this before. This shouldn't be new to you by now. So we're going to do dir in here. and we're going to try and run the program, and it's going to run. So it's not really giving us a runtime error here because we're not capturing this or trying to use the result of this division here. We're just doing the division, which is a problem. So let's try and capture this. We haven't learned about variables yet, but what we're going to do now is do int value, and we're going to assign the result of this division to this value. And let's try printing the result of dividing a number by 0. So we're going to do stdc out, and we're going to say value, and this is how you can print a value out on the console. Okay, now that we have this in, let's try and build. We're going to run task and build with GCC. We're going to get the same warning, but if we try to run the program, we're not going to get what we expect. Let's run rooster exe. We expect it to say hello world and print the value, but you see that it's really struggling to print the value, and it gave up and ended immediately. So this is one example of a runtime error that you can face in your program. There are many other kinds that we're going to see as we progress in the course. Here, we are just trying to raise your awareness on these problems so that you can know how to fix them when they come up. Okay, so this is all I can share with you now about runtime errors. We also had a chance to see that this is also going to give you a warning. And Visual Studio Code here is also helping out, telling us that we may have a problem. It's turning the main CPP file yellow, and it's saying that there is one problem in this file. And if you go here, you're going to see that we have a warning here. Okay, so this is one way you have to see this. So this is not recommended to do, so we're going to comment this out. Okay, this is really all I had to share in this lecture. We had a chance to look at compile time errors. We also had a chance to look at warnings and runtime errors using this example. If you get the warning, it is a message the compiler is giving you that you should really look it up and fix the problem before it becomes more serious. Compile time errors are going to cause your compilation to fail, and that's a really good thing because the compiler is going to stop you from generating a binary that doesn't really do what you expect it to do. So that's a good thing. But sometimes the compiler wants to give you a compile error, and you have a chance to run into a runtime error, and that's really bad. So be careful about these things, and when you have problems, Visual Studio Code is going to show you the problem in Terminal or in this Problems tab, and you're going to be able to fix it up. We're going to stop here in this lecture. In the next one, we're going to learn a little more about statements and functions. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about a little more about statements and functions in C++. A statement is a basic unit of computation in C++. You can say that it is the smallest thing your CPU can execute in your program. Every C++ program is a collection of statements, so you're going to have a bunch of statements that are organized in a certain way to achieve whatever it is you want. And statements in C++ must end with a semicolon. We saw in the last lecture that not putting that semicolon is going to result in a compile time error. Here is a basic sample C++ program that we're going to use to learn about statements. In the main function here, we have two variables declared. We haven't really learned about variables, but they are a way to store data in your program. And here we are storing two decimal numbers. One is called first number, the second is called second number. We can do something with these variables that we have in our program. For example, we can add them to have another variable in our program, and we can print that. So you see here we are saying stdc out, the sum of two numbers is sum. So this is going to print 21 because it's going to add 12 and 9, and the result of that is going to be displayed on the terminal if we run this program. What I really want you to notice is that this int first number equals 12 thing is a statement in C++, so it must end with a semicolon. The line here with second number is also a statement, so it must end with a semicolon. Every single line we have here in the main function is really a statement, and it must end with a semicolon. If we don't put the semicolon in place, we're going to get a compiler error. Okay, one other thing that is really really important to keep in mind is that statements are executed in order in your program, and the order is from top to bottom. If we go back to our program here, so the first statement is the one with first number here. 12 is going to be stored in memory when this statement is executed by your computer. And we're going to go to the second statement with second number, and we're going to keep going until we hit the end of the main function, and the return statement is going to execute. And when the main function returns or terminates, we're going to get the return value sent to your operating system, and it's going to know if your program ended successfully or with a problem, and the operating system is going to know what to do with that information. Execution keeps going until we hit the end of the program, or if there is any other condition causing for the program to terminate. And we're going to have more details about these things later. I just want you to know that the statements are executed in order in your main function. Another concept I really want you to have an idea about is the concept of functions. A function is really like a machine. You give it input and it's going to give you output. If we look at the operation here to add first number to second number, we can consider first number and second number as input to the function, and sum is the output of the function. We can visualize that like this. So we have a first number and a second number. We pass that into our machine, which is really a function, and we're going to get the result of this function in a return value or something that we get out of the function as our result. C++ has a special syntax we use to define functions. This is a function to add numbers. On the left, we have an integer, which is code name for a whole number in C++. It's a number without decimal points, and it's a whole number. After that, we have the name of the function, and we can name it whatever we want. And after that, we're going to have the list of parameters that we can pass to the function. And this is going to work as the input to the function. After you do that, you're going to have a pair of curly braces. The one is here, the other is here to the end. And within those curly braces, it's going to be the body of the function. Inside the function, you see that we are declaring a variable which is called sum, and we are storing the sum of first number and second number in this variable. And we are making this function return the sum as the result. And we're going to be able to capture it if we call this function in a function like main. You're going to see how this works in a minute. A function must be defined before it's used, so you can't really call a function you haven't defined first in your C++ program. And here is a slightly complete program to really put all these ideas together. We have our function to add numbers. It takes two numbers, first number and second number. It's going to add them up and store the result. And we're going to return sum to be used by whoever called this function. And if you look in our main program, we have a statement here. We're going to store the result of add numbers in the sum variable, and we pass first number and second number in the function, and we're going to have that result stored in here. Here, we also call the function with direct numbers. You see that we pass in 34 and 7, and we're going to print out the result here. This is the basic idea I want you to have about functions. They are reusable pieces of code that group together a bunch of statements to do whatever it is we want to do in that function. One benefit about functions is that we can reuse the code here. If you look here, we are calling this function multiple times without really rewriting the statements that are inside the function. I know some of these concepts might be cryptic to you right now. We are going to go to Visual Studio Code and try this in code, and you're going to see exactly how this works. Okay, here we are in our folder where we are storing our projects. I am going to grab the code from the template project. I am going to put that in the current project, which is statements and functions. I'm going to paste that in here, and I'm going to open this up in Visual Studio Code. I'm going to close the project we have right now, and I'm going to open our new project. Let's browse to its location. I am going to open the project on statements and functions. Let's open this folder in Visual Studio Code, and we're going to have our starter project here. I am going to take out whatever we have in the main function and take out this conteval thing. We don't really need it. And we are going to try and define two variables using two statements. We are going to say int first number, and we're going to put in a value, let's say 3, and we have to remember to end this with a semicolon. So this makes our statement. We can encode this in a comment to make this pretty clear. We're going to also define a second variable. So we're going to say int to mean that it is a whole number. It doesn't have decimal points like 2.5. It is a whole number like 1 or 7 or 10. So we're going to say second number. We can give it a name, and let's put in a 7. We're going to store these values in our program, and we can print these values out. Let's print them out first. So we're going to say stdc out. We already know how to do that, and we can say first number, and we can change these output statements and say the first number is first number. You can do that stdendl, and you can notice that Visual Studio Code is really helping out in auto-completing things we have in our program. Let's print the second number to really practice this. So if we do std, you're going to see that it's going to give us a bunch of options we can choose from. If you want, you can scroll through this with your mouse, or you can just type whatever you want to type. So I am going to do cout, and it's going to try and help out. If I really want, I can come on cout here and click on it, and it's going to be auto-completed, which is pretty cool. So we're going to say second number, and we're going to say second number here, and it's going to auto-complete for us. ENDL, and we can try and compile this program. Before we do, I want you to guess what we're going to get when we run this program. Give it a guess. We are then going to go to terminal, run task, and we're going to build this with GCC. The build is going to be successful. We're going to open this in our terminal. The terminal goes away, no problem. We're going to open it again, and we are going to go in our folder and do dir, and you're going to see that we have rooster.exe, our program. We can run it, and it's going to say first number 3 and second number is 7. This is what we have stored in these variables. And the benefit of storing your data in variables is that you can change the variables and let the rest of your program really do the same things and pick up the data that you have in those variables. For example, we can put 13 in the first number, and if we build again, this number is going to be picked up by this code, and we didn't need to go in and manually change data in these stdc out statements here. Let's build so that we can see this, and we can close this by clicking, and if we run rooster again, it's going to say 13 and 7. Play with this a couple of times until you really feel confident, and if you have any problem, don't hesitate to ask me. I am going to do the best I can to help you out. Now that we have these numbers stored in our program, we can add them up. Let's say int sum. We're going to declare another variable, and we're going to say it's equal to first number plus second number, and we're going to end this with a semicolon, and we're going to print the sum out. Let's do stdc out, and we're going to say the sum is sum. We're going to print our variable here, and we're going to print a new line character with stdendl. We're going to build our program so that our changes are reflected in our binary here. So we're going to go to terminal, run task.
This is the highest residential home on planet Earth. Welcome to the penthouse at Central Park Tower on West 57th Street in New York City. This apartment, the penthouse, are the top 3 floors, 129, 130, and 131. And it tops off at about 1,416 feet high. You have 360-degree views, not just of New York City, but you can literally see the curvature of the earth. There are 7 bedrooms and 11 bathrooms and 2 full kitchens. It also has the highest private ballroom and the highest residential terrace in the world. Central Park Tower has some of the greatest amenities. There's a private restaurant, cigar room, there's 2 swimming pools, indoor, outdoor, full-on spa, fitness center, a movie theater, and this is all on outdoor, full-on spa, fitness center, a movie theater, and this is all on the market now for $250 million. Let me show you around. This is the Grand Salon. This is the main living room space, if you will, for the apartment. It is massive, nearly 3,000 square feet just of living space. Your ceiling heights are over 27 feet high. The feat of engineering it took to build not just this penthouse, but this building, like, look how small the Chrysler building looks. Can you see that? Like, look at that little guy. And you've got all these other buildings. I mean, this is New York City. It looks so little down beneath us. That's 157 West 57. That was this developer's first tower on 57th Street. It really created Billionaires Row. Sometimes you'll see helicopters go by way beneath us because they fly at about 1,000 to 1,100 feet, and we're well over 1,400 feet in the air right now. So you've got this penthouse and it's here, and it's gorgeous and it's beautiful. It's obviously built for entertaining, but it's also built for living. I don't really play piano anymore. What I used to play is like the Woodchuck song. Anyway, I'm a broker now, so let's go to the dining room. So this is where you'll have your family dinners. We've got this really, really cool panda marble table here, and my view while eating dinner is the Atlantic Ocean out over Long Island. I mean, you can see so far. And I've got all of Lower Manhattan, the Verrazano, World Trade Center, Freedom Tower, Summit, and I'm looking right here at Times Square. While I'm eating dinner here, if this is December 31st, I could be sitting in this chair, having a glass of champagne, watching the ball drop. All right, let's go into the kitchen. The apartment has 2 kitchens. One formal kitchen, family kitchen, with everything you could possibly need, gorgeous stone. You're making a cup of coffee in your espresso machine that's, in your wall. And again, you've got the entirety of the city. While you're walking along the streets, the buildings that seem like skyscrapers look like a carpet from here. This is brand new, so no one lives here. So like you've got your pantry here, nice and pretty. Get your fridge and freezer. I'm sure they're totally empty. Yep, totally empty. Got the boxes of still have all the manuals and everything in here ready to go. Because when you spend $250 million, you definitely need to read the refrigerator manual. That's important, day one. So now we're in the breakfast room. All of the furniture is custom imported from Brazil. You've got your extra high ceilings. I love the wallpaper in here. It's kind of like these light colored waves. It's almost like you're in the clouds up here because you actually are. You have 2 bedrooms that are also on this floor. So you've got the core of the building, and then you have the entryway. So this is where we started, and I'll show you the conservatory. Now the elevator hits on all 3 floors. So you can get off on the 129th, 130th, 131st floor, and it's private. We took a telescope actually when I first got the listing and went up to the terrace. We could actually see.
Well, with GCC, the build is going to be successful. We're going to press any key. We are going to click here in the terminal, and we're going to hit enter and run Rooster again, and we should see the sum, and you see it says the sum is 20, which is what we expect. Now, we are doing the sum here, but it would really be better if we're not doing the sum in the main function here. What if we actually took this code and wrapped it in a function that we could reuse whenever we want? We have seen how we can declare a function. So let's do that. We're going to follow the same structure we saw in the slides earlier. So we're going to say int, this is going to be the return value, or what we get out of the function. Then we're going to put in the name of the function, we're going to say add numbers, and we're going to pass in the parameters. The parameters can really have any name you want, but you have to specify the type of the parameter first. So the parameters are also going to be whole numbers, like 1, 5, 7, or whatever you want. And we're going to say first param, and the second is going to also be a whole number, an integer, and it's going to be second param. Okay, after we do this, we're going to specify the body of the function, which is going to be between these curly braces. I am going to jump to the next line so that this is really easy to see. So I am going to define our sum variable inside the function. It's going to be a whole number, and I can call it whatever I want. So let's call it result, because it's going to be the result of this function, and the result is going to be the sum of first param and second param. Okay, I hope this makes sense. And we're going to end this with a semicolon, because every statement in C++ has to end with a semicolon. After we have the result, we need to give it back to whoever called this function, and we're going to do that with a return statement. And we're going to return the result to whoever might have called this function here. Now that we have the function, we can actually use it. We're going to go back in our main function, and what we're going to do is to reuse this sum variable and store in whatever is returned from our function. The syntax for that is going to be sum, and we're going to say equals, and we're going to say add numbers, and we can pass in whatever two numbers that we want to add up. Let's pass in 25 and 7, for example. We would expect this to give us 32. So if we print the sum again, we can just copy this statement that prints the sum and reuse it here. Let's align this a little bit, and I want you to take a guess at what we are going to get from this program right now. We have these two numbers, we are adding them up. If we get here, this should print the first number, which is going to be a 13. So here we expect to get 13, and by the time we hit this second number statement, we are going to print the second number. It's going to be 7. If we get here, we're going to print whatever is stored in sum, and in sum we have the sum of first number and second number. So this should print 20, right? And here we are doing another sum of two numbers, but we are using a predefined function that we have here before the main function, because you have to define the function before you use it. Okay, if we add 25 and 7, we are going to fall into this function, and it's going to add those numbers up, and we're going to get a 32 in here, and that's what we're going to return, and it is going to be saved in this variable. If we print it out, it's going to give us 32. I hope this makes sense. Let's build and run our program. Task build with GCC. The build is going to go fine. We're going to go back to our terminal here. Let's clear so that things don't disturb us and bring in some confusion. We're going to run our rooster program, and exactly what we have here. We have a 13 from the first statement here. We have a 7 from this statement here. We have a 20 from this sum here, which is here, and we have a 32 that we got from this function. The good thing about functions is that we can reuse them. Now that we know how to use it, we can use it again, and we can say sum equals add numbers, and we can say 30 and 54, for example. You add them up, and you're going to get the result. So we're going to print the result sum, and we're going to put in the sum. I really want you to take some time and play with this statement so that this things make sense. It's really not that difficult, but you just have to wrap your brains around how C++ defines these things. So we have this statement, and we are adding 30 and 54, so we should get an 84 after the 32 here. Let's build. We're going to run the task to build with GCC. We're going to click on the terminal here and hit enter. Let's clear so that we don't have things disturbing us, and we're going to run our program, and we have our trusty 84 here. I really hope this makes sense. And as a bonus, I'm going to show you that you can also call things in the std_cout statement here without having to store them in some predefined variables. And sometimes this comes in handy. So you can say std_cout, and we're going to say sum, and you might say add numbers right in here, and you're going to say 3, for example, and 42, and this is going to give us a 45. That's what we should expect to see after 84 here. So let's build and run the task to build with GCC. The build is going to be successful. We click on the terminal here, we hit enter so that we see our terminal with output. We're going to clear so that we see our output without noise. We're going to run our program, and we're going to see a 45 here. I really hope this makes sense. The whole point of this lecture was to make you aware of statements and functions. A statement is the most basic unit in your C++ program. It basically lives on one line, but it can also spread across different lines, but we're not going to look at that here. Maybe we're going to see that later in the course. Statements are executed in order, so when our main function gets to be run by the computer, it's going to go from the first statement, second statement, third statement, and it's going to go until it hits the end. And we can see that here, in the order in which our numbers are printed, it is going from top to bottom. We have also seen that we can split our code in different functions and wrap whatever functionality we have in a function. We have seen the basic concepts on functions. A function has a return value, it has a name, and you have to give it the parameters, and you put the value of your function within these two curly braces. As an exercise, I would challenge you to do a function that multiplies two numbers and call it in the main function here to see the result. If you have any problem, please do ask underground, under the hood, the data. This is going to be the return value, or what we get out of the function. Then we're going to put in the name of the function. We're going to say add numbers, and we're going to pass in the parameters. The parameters can really have any function, and it's going to add those numbers up, and we're going to get the 32 in here and run after the 32 here. Let's build. We're going to run our execute it in order. So when our main function gets to be run by the computer, it's going to go from the first statement, second statement, third statement. We have function has a return value, it has a name, and function inputs in our program and from our C++ program. Go ahead, interesting. We're going to stop here in this lecture. In the next one, we're going to see how we can input and output things from our C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about how we can get things in our program and get things out of our program. And that's basically input and output to and from our program. We have actually been doing this all along. We have been printing things from our program to the console. And with this technique, you can really think of stdc out as a highway that goes from your program to the terminal. You can basically think of it like this. Data is going from your program to stdc out, and it's going from here to the terminal. And from this, you might get an idea why these less than signs kind of point to the left. Because data is going from your program to stdc out, and these two symbols point to the left. They point to stdc out to signal to the fact that data is going from here to here. I really hope this makes sense, because sometimes these things can confuse people. This is the reason why it's going from your data to stdc out. Data is basically going from your program into stdc out. And stdc out is one way we have to get data from our program to the console. There are many others. We have stdcerr or stdcir. This is what I like to call it. And what it does, it prints errors to the console. We have stdclog, which is going to print log messages. Why do we have these different things? Different programs might decide to format these messages differently because they are different messages. One is a simple message from the program, another is an error. You might want to turn this red to really bring the attention to this message because the user has to solve that problem. Another might be a log message that you want to store in some file or some database. Uses for these things differ, and C++ makes sure to give you different ways to state your intent through the tools that you use. We have looked at stdc out, stdcr, and stdclog. What does stdcin do? It does the reverse. It's going to take data out of the program and bring that into the program. So let's look at a few examples using these. Here we have an example of printing data from the program to the terminal through cout, cr, and clog. Here we have a hello world message going to cout. Here we have a number going to cout. This is what we've been doing all along. We can also do a variable storing the age, for example. It's a whole number, it's an integer. So we print this out, and the message is going to go from the program to cout. So you can think that things are going from the program to stdcout. I really wanted this to make sense. Okay, if we go down, we're going to see that we can use cr to print errors to the terminal, and we might say something went wrong or something along these lines to bring the attention to the problem. And we can use clog to print log messages, and they work the same way. They all use the stream output operator, and it is going to take data from the program to the output stream really. This is what we mean here. Here is an example of how you might read data and bring that into the program. Here we have two variables. One is the age, it's a whole number or an integer in C++, and the other is a string. This is a type that allows you to store strings in C++. We're going to learn a little more about this later, but here I want to use it to really make it clear that you can get things from the outside and bring that data in your program. So we're going to let the user type in the last name, and this statement here with CIN is getting data from the stream or from the highway through which data comes into our program and bringing that in our program. And here it should be clear that the flow of data is in this direction. Data is going from CIN, and we're storing that in a variable that we have in our program that is called name. We do the same thing and ask the user to print the age, and they are going to print that, and the data is going to come from CIN, and we're going to store that in our age variable here. After we collect the data from the user, we're going to print that, and we're going to say hello, we're going to print the name, and we're going to say they are whatever years old. This is what this program does, and I really hope it makes it clear how data input works through streams in C++. Another thing we can do with stdcin is chaining input, and we can use this technique to grab data in one statement. Look at the program down here to really understand this. We have the same variables, age and name. We let the user type in the last name and age separated by spaces, and we grab the data like this. We first grab the name, after that we grab the age, and we're going to print the same things, and we can chain input stream operators like this to grab the data in one go, and this may come in handy sometimes. Before we try these things in Visual Studio Code, I want to bring your attention to a problem that you are likely to come in contact with, and that is reading data with spaces. What if the user types the name with spaces? For example, you ask me to type my name. I'm not going to type Daniel, I'm going to type Daniel Kapuaya, and your program is going to run into problems. C++ allows to solve this problem using std_get_line, and you use it using this syntax. You're going to pass in the stream where the data is going to go, and you're going to pass in the variable that is going to read the data, and you're going to have this information stored correctly in your program. This might be not making sense yet to you. We're going to go to Visual Studio Code and play with us, and I am sure it is going to make sense. Okay, here we are in Visual Studio Code, and we have our project where we're going to store our files, data input and output. We're going to copy code from our template project, and we're going to put the data in, and I'm going to open this folder in Visual Studio Code. So let's close whatever we have now, and I'm going to open my folder. Let's browse there. I am on this folder, data input and output. I'm going to select that, and the project is going to open up in Visual Studio Code. I am going to jump to my main function. I am going to take out things we don't need, and the first thing we're going to do is printing data. We have already done this, so we're going to practice this a little bit. We can say stdc out, and we can say hello C++ Wayne. Why not? And we're going to put an stdendl at the end, and remember our semicolon. And here I want you to really put in your head that data is going from our program here to stdc out, and stdc out is going to dump that on the terminal. That's how this works. You can also do a variable. Let's say int age, for example. Let's say 21, and end this with a semicolon. And we can also print the age. We can say stdc out, and we can say age. This is going to be sent to the output stream, and we're going to do stdendl to add a new line character at the end. And we can try and weld this before the program gets more complicated. Let's go to terminal. We're going to run the test weld with GCC. And if we hit enter on the terminal here, the terminal is going to go away. We're going to create a new one, no big deal. And if we do there, we're going to find our Rooster program. If we run it, it's going to say hello C++20, and the age is going to be 21. We are successfully taking data from our program and putting that to the terminal. This is pretty cool. And you can think of SDDC out as a highway that is really going to take your data from your program and bring that to SDDC out like this. We're also going to take the age, it's going to go through SDDC out, and it's going to show up here. You can think of this like this. Okay, now that we have used SDDC out, we can use SDDC and SDDC log in the same way. So we're going to say SDDC and we're going to say error message, and the message is going to be something is wrong. You may do whatever you want in here, and we have to remember to put a new line character, otherwise data is going to be cramped on one line. We can also use SDDC log. It really works the same way, C log, and we can say log message, and we're going to say something happened. And we remember to put std, endl, and our semicolon. If we build this program, you might guess what it's going to do. It's going to print these things on the terminal, but this might be useful to terminal programs that support features to format different messages directly. The program is going to know that one message is a simple message, the other is an arrow, the other is a log message. Let's run our program, but before we do that, let's clear so that we don't have noise here. We're going to run the program, and it's going to say the error message and the log message here. Okay, now what we're going to look at is how we can get data into our program. And data is going to be going in a different direction. It's going to be coming from the terminal and flowing into our program. What we're going to do, we're going to do int age1. This is a new variable, so we're going to put in data, and we're going to bring in a string library to allow our program to store strings. The way we're going to do that, we're going to include string. This is how you do it in C++. We haven't really learned about this type. It's a powerful type in C++, but we will get there when we have more powerful tools to really understand it. We are just getting started here. So what we're going to do, we're going to say std string, and we're going to say name, and we're going to ask the user to print their name and age. You already know how to do that, so we're going to say please type your name and age, and we're going to do std endl on this. And how we're going to get data in the program, we're going to use stdcin, and we're going to do stdcin, and that is going to be going from the stream to the program. So the stream input operator here points to the right, and the data is going to be going in the name variable because that's what they're going to be typing in first, because that's what we told them to do. So we're going to store the name, and we're going to say stdcin. That is going to be flowing from stdcin into our age1 variable. Okay, now that the user has given us their information, we can greet them with a personalized message. We're going to say stdcout hello, and we're going to put out their name, and we're going to tell them you are, and we're going to put the age 1, because that's what they're going to give us here, and we're going to say years, and we're going to put an stdendl here. I'm going to here, and we're going to say years, and we're going to put an stdendl here. I'm going to grab this and pull this to the left so that we can see our entire program here. That's helpful. So what we are doing here, we are getting data from the user, and we are storing that in our variables, and we are printing the message so that the user can see it. I don't want the first things we did here to disturb us when we build and try this out. So I am going to comment this out and comment the first block of code out using block comments. I think this is the first time we use this, and this is going to comment the first block of code out using block comments. I think this is the first time we use this, and this is going to be ignored by the compiler now, and it is only going to consider this, and this is going to be pretty cool. Let's go down a little bit here and try to build the program. We're going to run the task that builds with GCC, and looks like the build is good. We're going to hit enter, and we're going to clear so that we are not disturbed by this. We're going to run the program. Let's say rooster.exe. It's going to ask me to type my name and age. My name is Daniel. I'm going to type that, hit enter. It's going to want me to type my age, so I am going to say 33, for example. and it's going to tell me, hello Daniel, you are 33 years old. I put a slash here. We can try and run it again so that I don't have to make that mistake again. So Daniel, name and age. My name is Daniel. I'm going to type that, hit enter. It's going to want me to type my age. So I am going to say 33, for example. And it's going to tell me, hello Daniel, you are 33 years old. I put a slash here. We can try and run it again so that I don't have to make that mistake again. So Daniel, that's my name. I hit enter, I say 33, and if I run, it's going to say, hello Daniel, you are 33 years old. I really hope this brings the point home that STDCIN is a highway that takes data from the terminal into your program. So this is really what is happening here. When I type Daniel, it's going to flow from the terminal and it's going to go into my variable, which is name here. And when I type the age, it's going to go in my age variable here. And all these happening through STDCIN here. Okay, one other thing we can do is grab the data and put that in our variables in one go. So what we can do here is comment this out, and we're going to do stdcin, and we're going to put that in name, and we're going to change these two things and put the other piece of data in age1. If you run the program, it's going to work exactly the same way, but we are grabbing the data in one line. So let's weld to see this in action. We're going to run the task that welds with GCC. We're going to click here and we're going to clear. If we run Rooster, it's going to ask for the name and the age. I'm going to put in Daniel, and I'm going to put my age and say 33, for example, and it's going to do exactly the same thing, but we have one compact line. The last thing I want to show you in this lecture is how how you can grab data with spaces, because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear, and I'm going to run Rooster again, and I'm going to say Daniel. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So C++ provides a way to solve this using std_getLine. So let's see what we are doing here. And before we play with this, we're going to comment out what we had here so that it doesn't disturb us in what we are about to do. So let's come down here and say that we were doing data input. This is helpful here. And we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I am going to stdc out. So the way I'm going to grab the data, I'm going to do std_getLine. You see that we have this function here, and it's going to take an input stream. So stdcin is going to work. And the second parameter is going to be the variable where this string data is going to be stored. We're going to pass in our full name, and this is going to work just fine. And we're going to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age3 variable. Once we have the data, we can greet our user using the same message we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring this to the same location. It's going to be full name here, and it's going to say age3. And let's try and build. We're going to terminal, run the task. It's going to be full name. Name here, and it's going to say age3. And let's try and build. We're going to terminal, run the task to build with GCC, and we have a problem because we forgot our semicolon. See how these problems might come to you? So we're going to put in our semicolon. And another thing I really want you to see is that you can bring these things to the next line if they turn out too long, like we see here. So I can, for example, put this to the next line, and it is going to work just fine. So what I am going to do, I'm going to try and build again, run task to build with GCC. You see that the build is good. We're going to bring in our terminal. I'm going to clear so that we don't have noise here, and we're going to run our program. It's going to ask me to put in my full name. I'm going to say Daniel Gakwaya, and it's going to want the age. I'm going to say 33, and it's going to greet me. Hello, Daniel Gakwaya, you are 33 years old. We are able to bring data with spaces into our program.
The rings on Saturn from the terrace because we were above the light pollution. And speaking of rings, this chandelier is by Cameron Design House, and it's these two oversized rings that really, really highlight the space and show the volume of this room. And then the conservatory leads right into the office. This is where things start to get very sexy. We have this kind of corkboard wallpaper throughout, these huge shelves. Again, this massive, massive view. And then look at this chair. This is where I'm gonna do this deal. Could you imagine this as your home office? Could you imagine if this was your Zoom background? So if you follow me back down the entry foyer, now for the internal staircase. So to really, really experience this moment, you have to look up. The stair atrium is 45 feet high, nearly 50 feet. And you'll see as we go up, but this is not a spiral staircase, it's winding. It's a massive amount of volume that goes all the way up, like the paths of Central Park, which is your backyard, right here. So follow me. It's pretty spectacular. Like just to have this as your view. The second floor has the majority of the bedrooms. The entire floor that faces the park is for the primary suite. You have 2 5-fixture bathrooms, all with imported stone. So this thing is massive and had to be like craned in as part of the construction. I don't take baths, but if I owned this apartment, I would bubble bath at least every 4 days. And every finish, like every piece of stone, every piece of wood, everything is basically the Rolls Royce of finishes. They went and found the highest end of everything. And you don't have to have any window treatments in here either because you are so high. Like who's gonna see you? NASA? So you have 2 huge walk-in closets here, and then this is your bedroom. This is what you wake up to. Like, could you imagine? You're just like, oh God. Oh, it's a Monday. Oh, it's a Monday, and I live in a $250 million penthouse. They say money doesn't buy happiness, but it's hard not to look at this view and not smile. It's wild. All right, now let's go upstairs to the private ballroom. This is the highest private ballroom in the world. There's actually over 12,100 individual pieces of glass in the entire tower. So you could have an event here with 200, 300 people easily. It is that big. Private elevator all the way up. The glass is super, super thick. At 1,416 feet in the air, you're above sound. Sound will start to dissipate as it travels up glass at about 100 floors, give or take. So what you hear up here is the wind, the noise, airplanes, helicopters, and that's it. I mean, these windows are 12 feet high, and this is only one level. Off the ballroom, you have this full-on chef's kitchen. 1, 2, 3, 4, 5, 6, 7, 8 different freezer and refrigerator drawers, a massive chef Sub-Zero, and then through that door, you have a host of other rooms that can be for private gyms, for security, different guest rooms, prep spaces, nannies, live-ins, etc. Goes on and on and on, but the floor plate was really, really, really well thought out. Let's go back to the ballroom. You would host a fundraiser here, a charity event. You could have amazing dinner parties. I mean, it's a ballroom. You could have a fashion show. You could have a basketball court in here if you wanted to. It's really up to you. I mean, this place is pretty big, right? So I've sold a lot of penthouses in my life. Never before have I had the opportunity to sell a penthouse with a terrace like this. So now we're on the highest terrace on Earth. You have 10-foot triple pane glass.
And this concludes what we had to say in this lecture. I hope it made it very clear what these STD-in and STDC out things are. They are basically highways that take data out of your program or bring data into your program, and the way you use them is what we've done here in this course. I would encourage you to play with this a couple of times if this is the first time you're doing this. We are going to stop here in this lecture. In the next one, we're going to try and recap on the C++ development workflow. Go ahead and finish up here and meet me there. In this lecture, we're going to explore the C++ execution model and show you a simplified version of the memory model of your C++ program. Here is how our program looks. It is a simple program. In our main function, it is going to call a simple function that is going to add two numbers. We have seen a program like this before, and when we compile it, it's going to be turned into a binary. This black icon here represents the binary executable, and it is not in the format that you can read with your eyes. If we come back here to what we were doing in the last lecture, we can see our Rooster executable binary here. If we try to open it here, you're going to see that Visual Studio Code is going to say the file is not displayed in the editor because it is either binary or uses an unsupported text encoding. So it says, I can't really say this because it's binary. And it says, do you want to open it anyway? If I try to open it, it's going to be just some gibberish. Because this is binary, it is meant to be read by programs. It is not meant to be by IDEs or text editors like Visual Studio Code. So this is the binary file we have here. I tried to put a simplified version of this program to represent binary so that we can follow it up, but it is not in a form that is readable by any human out there, unless you are a machine. So why is it in binary? Because binary format is easily understandable by your CPU. And we're going to see how your program is loaded in memory and executed statement by the CPU so that you can really understand this. So here is a representation of your program. Here we have our hard drive, and we have the program sitting somewhere on our hard drive in binary format, and it's waiting to be run by you by double-clicking on it or opening it in the terminal. And on the left here, we see a representation of the memory of our computer. And when I say memory, I mean random access memory. I don't mean memory on your hard drive. This should be really clear. This is the random access memory of your computer that is running your programs very fast. So when you double-click on our program, or if we open it in the terminal here, and to say name, and we're going to ask the user to print their name and age. You already know how to do that, so we're going to say, unless you are a machine. So why is it in binary? Because binary in code, it's going to be really easily understandable by your CPU. And we're going to see how your program is loaded in memory and executed statement by the CPU so that you can really understand this. So here is a representation of your program. Here we have our hard drive, and we have the program sitting somewhere on our hard drive in binary format, and it's waiting to be run by you by double-clicking on it or opening it in the terminal. And on the left here, we see a representation of the memory of our computer. And when I say memory, I mean random access memory. I don't mean memory on your hard drive. This should be really clear. This is the random access memory of your computer that is running your programs very fast. So when you double-click on our program, or if we open it in the terminal, the binary file is going to be loaded up in memory. And you see it in red here. This is a representation of that. And it is ready to be run by the CPU. By the time the CPU sees in the memory location, it's going to know I have a program to run. And the CPU is going to start running it statement by statement. It is going to start by the top. So it's going to see that it needs to allocate space to store our integer A. It's going to allocate that somewhere on the memory. In yellow here, you see A. And it's going to see that it should store in a value of 10. And it's going to do that. You can see that here. It's going to go to the next statement. And the next statement tells it to allocate space for a value B. And it's going to store in a 5. It's going to go to the next statement. It's a variable called C. It's going to allocate space for it, but we didn't specify a value for C. So what it's going to do is store in some junk value. The value in there is really unspecified at the moment. It's going to jump to the next statement, and what it's going to do is print some things on the console, and it is going to do that. It's going to jump to the next statement, and it is going to print statement 2, and here it is going to notice that it is going to call a function. I don't know if you have noticed, but the CPU has allocated a special memory location for our function. The function doesn't live with our code here or anywhere near the variables that we have here. There might be a huge chunk of memory between these 2 or 3 things. So the CPU knows that it is going to jump to another location. It's going to ask itself, if I jump to that location to run this function, how am I going to come back? And the CPU is smart enough to store the return address. And that's what it's going to do. It's going to say, if I go to that function, I want to come back to the address 6 and run whatever is after this address. So it's going to store 6 in CPU memory, and it's going to jump to the function. It's going to take the first parameter as A and the second parameter as B. So A is 10. The parameter 1 is going to be 10. It's going to take parameter 2. It's going to be 5 because it is B here, and in B we have a 5. And it is going to jump to the next statement in the function, and it is going to add up parameter 1 and parameter 2. After it adds those things up, it's going to return the result to C. We can see that here. Okay, that's what the CPU is going to do. It's going to put the result in C, and the result is a 15, so we're going to write that in there. And now that the function is really done, it's going to come back to its address, and it is going to jump to the next statement after that. It is going to print 3, statement 3. It is going to jump to the next line and print statement 4. It's going to do that, and by this time, we have reached the end of our program, and it is going to be popped off the memory, and your program is basically going to end. This is how your program is executed by your CPU. And why am I showing you this? Because it is really good to have an idea of how memory is allocated and used by your program. Another good reason is that some C++ features require you to have an understanding of a memory model like this to understand how they work. For example, you have seen that to call this function, the program had to jump from address 6 to 30, and this is really heavy, especially if you are running a simple function like we are doing here to add 2 numbers. So the CPU can realize that and optimize this call to the function to an inline function and add these 2 numbers up right here at address 6 without jumping to this address here. And this may come in handy, and you need an understanding of this memory model to really understand these features. This is just one example I am giving you. You are going to reuse this model a lot in your career as a C++ developer, and I thought it was a really good idea for you to understand it firsthand. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to try and understand the difference between 3 key components of the C++ programming language. Go ahead and finish up here and meet me there. In this lecture, I want to highlight the differences between what we call a C++ core language feature, or a standard library feature, or an STL feature, because these are terms that come up a lot if you happen to read some documentation about C++. A core feature is really a basic building block that makes up the C++ programming language. You can think of it, for example, how you define variables, the rules that govern how you can define and use a function in C++, the rules that say what you can do and not do with the basic features of C++. That's really what can be qualified as a core feature of the C++ programming language. I don't know if that makes any sense. If we come back in Visual Studio Code, we have a program we have used in the last few lectures. For example, these basic types that you use in C++, the rules that define how you can define a function. For example, if you put an angle bracket here and try to compile this program, it is not going to work because we have violated the rules of the C++ programs. The basic rules that define how the C++ programming language works, the basic types that are defined in the C++ programming language, these little things make up the raw ingredients you use to make up a proper C++ programs. And these little raw components that you use to put together a C++ program are called core features. You can think of them as the foundation on top of which we really build daily use C++ programs. The standard library is a set of ready-to-use, highly specialized components that we can easily use in our C++ programs. And again, coming back to our program in Visual Studio Code, IOStream here is a standard library feature. String here is a standard library thing we have in the C++ programming language. And again, the C++ standard library tries to provide highly specialized components that we can use in regular C++ programs. When you use the C++ programming language, you don't really want to extend the C++ programming language. You want to use it to build something of your own. And the standard library features are things to use to work on your programs very fast. For example, we have used stdc out without really going into the details of how the data is taken from this program to the terminal. That's really advanced and probably complicated, but it is wrapped into this reusable components, and one of them is IOStream, and we can use it relatively easily in our C++ program. Okay, I hope now you have a better idea of what the C++ standard library is. Now, what is the STL? The STL is really part of the C++ standard library, but it is a collection of container types. Think of them as collections of things. And we have a set of types that allow us to store collections. We have algorithms or functions that work on these collections, and we have specialized types that are called iterators that allow us to navigate through these containers, potentially running these algorithms on each element in the collection. This is probably not making sense by now, but you can think of the STL as a highly specialized part of the C++ standard library. And we're going to learn about many features of these things throughout the course, but I want you to have a basic understanding between these 3 terms: a core feature of the C++ programming language, a standard library feature, and the STL. And I really hope this is clear to you by now. In this chapter, we're going to learn about variables and data types. Before we talk about variables and data types, I would like to take a moment and recap on what we know by now. And if you look at these cards, many of these things should make sense now. You know about the main function, you know that it is the entry point of your program, you know that your program is going to be made up of statements and with a semicolon in C++. You know about functions, errors, warnings. You now have an idea about how you can handle input and output from your program. You can use comments. You know about the memory model and the execution model that we talked about in the last lecture. You know quite a lot. Now, we have been using a program like this to do things in the last chapter, but there is one thing that isn't really explained yet, and that is this int. This int is a type that is predefined in C++, and C++ predefines many types. Here we have a couple of these types for you to see as examples. Int is one of them. We have seen it a lot of times in the last chapter. It is used to represent whole numbers like 1, 2, and 3, but we have others. For example, double and float are used to represent fractional numbers, numbers that have decimal points. For example, 2.5, 7.3, and numbers like that. And we're going to see the difference between these two. Another one that is commonly used is char or car, and it is used to represent characters in memory, and you can store in characters like A, B, C, and D, and all the other characters you can really put in. We have a bool, which is a type that is going to store 2 possible states. The only values you can really store in here are true or false, and we're going to see how this works. Void is somewhat confusing because it represents a typeless type, and it is really meaningful when we get to talk about functions in detail. So we're going to learn more about the void type a little later in the course. We also have the auto type, which is really not a type. It is a keyword you use in C++ to deduce other types, and we're going to see how this works later in the course. These are a few examples of types we can use in C++, and we are going to play with most of them in this chapter. Another thing I really want you to see is what does it mean to really put a for in a variable in your program. Everything you have in this program here is represented by 1s and 0s in the computer's memory. It really looks like this. It's a bunch of 1s and 0s in the RAM of your computer, and there must be a technique to make sense of this gibberish here and store data that makes sense to humans. And the starting point is to group these 1s and 0s into little chunks that we can manipulate. Each of these 1s and 0s is called a bit. So this 0 here is a bit, this 1 here is a bit. And if we group 8 bits together, they are going to form what we call a byte. Okay, if it makes sense, you can group your bits in a byte. bytes, or if it makes sense to group them in groups of 16, you can do that like we see here. We're going to see a little more details about this in the next lecture. Okay, here you see that if you really want, you can treat each bit as a self-contained piece of data, but this is really not very useful, but there are some corner use cases for this. Okay, now we really have two sides. On the right, we have data in the format that is really convenient and understandable by humans, and on the left, we have how data is represented in memory. So there must be a way to transform between these two forms of data, because humans can't really handle these ones and zeros well. And we do the transformation between these two representations of data using number systems. We have a few number systems available to us that we can use. Binary, octo, hexadecimal are a few examples, and we're going to learn about them starting in the next lecture. So go ahead and finish up here and meet me there. In this lecture, we're going to learn a little more about number systems. Number systems allow us to transform data from the form that is really convenient for humans in a form that is convenient for computers, in these ones and zeros that you see on the left. We can also use them to do the reverse, to go from ones and zeros and go in the format that is convenient to humans, like this 22 or this Steve name here. To make sense of how these number systems work, let's analyze the decimal system that we really use in daily life, and that is usually called base 10. So if you look at this 2371 number here, we can really split it in the form that you see to the right here. If you try and take this expression we have on the right here and evaluate it, you're going to get this number here. 2 times 10 to the power of 3, this evaluates to 2000, and this one here is going to evaluate to 300, this one is going to evaluate to 70, and the last one is going to evaluate to 1, and if you add these things up, you're going to end up with this number. So this is how we can take a number and make up a base 10 representation of it. We can do the same thing for 924 here or 47 here. It really is basic math. You don't need to have a lot of background in math to make sense of this. So we're going to use this exact form and understand binary numbers. If you look at what we have here, we have a few binary numbers that are made up of ones and zeros. That's why it's called binary, because you can only have two states, or 0 or 1 in your numbers. So we can really do the same thing. We are in base 2, so instead of using a 10 here, we're going to be using a 2, but it is the same operations we really did. If you take this and multiply and add these things up, what you're going to end up is a base 10 representation of this number. If we go in the middle here, we have something we can easily do without using a calculator. The expression on the left here is going to evaluate to 0 because we are multiplying with 0. The second one is going to be a 2 because we are taking 1 and multiplying this by 2. The others are going to be zeros, but the last one is going to be 2 to the power of 4, which is 16, and way to add a 2, and this is going to evaluate to 18. We can actually bring up our calculator on Windows 10. I think it can help in this a little bit. We're going to bring it up, and we want to put it in a programmer mode, and we're going to go back on our slide and find our number, which is 10010. So we're going to type it out, 10010 in binary. This is binary that we have typed here, so let's clear this and do 10010, and you're going to see that in decimal it is 18, which is what we came up by computing this in our brain. Let's try the one we had before that we couldn't really do in our brain. We're going to say 1001001. Let's do that. We're going to clear 1001001. This is going to evaluate to 37 in decimal, and you can use calculators like this to really do the transformations between these different number representations. Okay, down below we have a 111, which is going to evaluate to a 7 in base 10. Okay, if we have 3 digits, we can really represent numbers between 0 and 7, and you see a table here that is going to prove that. 000 is going to evaluate to 0 in decimal, 001 is going to be a 1, and if you go down to 111, that is going to evaluate to a 7. You can try and use a calculator to prove this and really understand how this works. If we use the 3 digits representation, our numbers are going to look something like this in memory. We're going to take the bits in memory and group them in groups of 3, and we are going to use binary to actually make sense of these numbers. For example, here on the left, this is going to be a 1, the second one from the left is going to be a 6, and this is going to be a 6 as well. This is going to be a 0, this is going to be a 3 because we have 1 and 2 here. We add those up, we get a 3. If this doesn't make sense, you can try and use a calculator. You're going to see that it makes sense. Okay, so what if we want to group our digits in groups of 4? We can do that, and we're going to end up with something like this. The values we can represent are going to go from 0 all the way to 15, and you can try and prove this using the calculator like we just did, and it is going to look like this in memory. So what we really are doing is grouping the bits in different sizes of data, and we have a kind of formula that we can use to make sense of the data in memory. For example, on the left here we have 0110. If we go back to our table and define 0110, this is a 6, and we're going to know that these 4 bits here are really storing a 6, and there are ways you can manipulate this in your C++ program. We're going to see that. You can also use 5 digits, and you're going to end up with something like this, and the numbers are going to go from 0 all the way to 32, and this is how it's going to look in memory. You can try and come up with what this represents in decimal. So going to go from 0 all the way to 32, and this is how it's going to look in memory. You can try and come up with what this represents in decimal. I'm not going to tell you this, but we can try and figure out the one on the left here. So it is 01101. If we go back, we're going to come up to 01101, which is a 13 here. So this memory location, these 5 bits represent a 17 number. So if we want to kind of generalize what we have talked about in the last slides, if you have 1 digit, you can really represent 2 states, 0 and 1. If you have 3 digits, you can represent numbers between 0 and 7, and you can go all the way down. And if we generalize this in a mathematical formula, we can say that if we have n digits, we're going to be able to represent between 0 and 2 to the power of n minus 1. And if you try to plug in any number of digits, you're going to see that this formula works. Okay, so these are a few grouping of bits we have in practice. We can use 8 digits and we can represent numbers between 0 and 255. If we have 16 bits, we can represent this range. If we have 32 bits, we can represent this range. If we have 64 bits, we can really represent a really huge range. I can't even say this number. It's really big. Okay, now you should have a pretty good idea of the binary system and different representations we can use to make sense of binary numbers in a computer's memory. The last thing I want you to see is what we call hexadecimal number system. And it is a technique we use to shorten the length of how we represent a binary number in memory. How does it work? Well, we take our number and split it in groups of 4 bits. And each group is assigned a symbol we can use to represent it. If we have 4 zeros, that's going to mean a 0 in hexadecimal. If we have 0001, we're going to represent a 1. And you can see that if we go up to 9, this is really similar to what we have in the decimal number system. But once we hit 10, we're going to represent that with an A in hexadecimal. 11 is going to be B, 12 is going to be C, 13 is going to be D, 14 is going to be E, and 15 is going to be F. So how do we use this to represent binary numbers? Let's see an example. Here we have a huge number that we represent in memory. It starts with 0 and ends with a 1 here. So the first thing we're going to do is to split this in groups of 4, and the one on the left is going to be a 1, 1, 1, 1. If we come back to our table here, 1, 1, 1, 1 means F. So we're going to represent this with an F. If you go to the second group of 4 bits, we have 0011. If we go back, 0011 means 3. So we're going to have a 3 here. I hope this makes sense. And we're going to keep using the same transformations, and we're going to come up with 1F03E6. And we can represent this binary number using these symbols. You can see that we go from using 32 bits to using 1, 2, 3, 4, 5, 6, 7, 8 symbols to represent this. And this is shorter and easily manipulable by humans. And we use a 0x in front to mean that this is a hexadecimal number. I really hope this makes sense. So if we have numbers that don't really fit in groups of 4, we're going to go from the left and split this in groups of 4, and we're going to end up with a group on the left that doesn't really meet our requirements. And what we can do is add the missing bits and make them zeros, and we call this operation padding. This is what you can do to really represent any number in hexadecimal if you don't have enough bits on the left. We also have another system that is really not widely used today, but I am mentioning it here for completeness. It is called octal system. It goes from 0 all the way to 7, and we can divide our binary number into groups of 3 and represent using these zeros and ones to shorten the length of the binary number. We can really do the same thing we did with hexadecimal. So we're going to take our binary number and divide this in groups of 3. The one on the left is going to evaluate to a 7 because it's 1, 1, 1, and 1, 1, 1 evaluates to 7 in octal system. The second one is also going to be a 1, 1, 1. The third one is going to be 1, 0, 0. If we go in our table, it's going to be 1, 0, 0. It's going to be a 4, and you see we have a 4 here, and you can do the same things until you have figured out the entire number here. And you see on the left we are doing padding and adding a missing bit and making it a 0. So we are coming up with 0, 0, 1. And if we go back to our table here, 0, 0, 1 is a 1, and that's what we put here. So we're going to put this number here. It's going to be 15, 61, 41, 70, 47, 7, and we're going to add a 0 in front to mean that this is a number represented in the octal system. I really hope this makes sense. Okay, so we have seen all these binary numbers and different number systems we can use to represent them, but how do we use them in a C++ program? Well, I'm glad you asked. Here is a simple example of how you can represent the number 15 through different number systems in C++. If you just say 15 like this, it's going to be in decimal. If you add a 0 in front, it's going to mean that the number is in octal system. So this can be confusing sometimes. If you do 017, it's not going to be 17. So if you say 017, C++ is going to interpret this number as if it is in octal system, and it is going to turn this into 15. Down here you see the same representation in hexadecimal, so that you use a 0x in front to represent that it is in hexadecimal, and this is going to be 15 in memory. And here we have representation in binary using zeros and ones, and you use 0b in front like this. I have to say that this was only possible since C++ 14, so if you are using an older standard of C++, you won't be able to represent binary like this. And if we run this program, it is going to print the same thing. It is going to print 15, but we stored the number using different number systems. Let's go to Visual Studio Code and try this out. Okay, here we are in a folder I have on my system where I am going to be storing my projects for this chapter. The first thing I am going to do is copy code from our template project. I am going to go in and copy things over, and I am going to put these in for 2 number systems. I am going to open this folder in Visual Studio Code, so I am going to go to File, close the folder we have now, and I am going to open up a new one, open folder, and I am going to browse to the location of my project. I am going to open this project here that says number systems. We are going to get rid of the welcome screen and open our main CPP file. We're going to get rid of this const eval thing and clear everything we have in the main function here. The first thing we want to do is to store an integer that is 15, and we're going to say int number1, the exact same thing we had in the slides, and we're going to store 15 in this variable here. This is going to be represented in decimal, and if we want to store the same number in octal, we saw that in our slides we could store this as 017. So let's do that. We're going to say int number2, and we're going to store in 017. This is not going to be 17. This is going to be a representation of a number in octal system. So we're going to say that this is octal, and we can represent the number in hexadecimal as well. So we're going to say int number3, and it is going to be 0x because it is hexadecimal, and we're going to say 0f. This is how we represent it. You can use lowercase or uppercase. It won't really matter. Let's use uppercase here, and we can use binary because we are using C++ 20. So we're going to say int number4, and we're going to store in a representation of 15 in binary, and it happens to be 4 zeros and 4 ones, and we have to prefix this with a 0b. This is how it works. So this is going to be in binary, and if we print all these numbers up, we're going to see, let me not tell you this, what do you think we'll see? Okay, so I went ahead and typed this out. What do you think we will see when we build and run this program? Before we do that, we're going to open a terminal so that we see it here, and we're going to go to terminal, run task. We're going to build with GCC. Let's wait and see if the build is successful. Build finished successfully. We have our Rooster program in here. We're going to click somewhere in this terminal, and our terminal is going to show up. If we do dir, you're going to see that our Rooster program is here. And if we run it, I want you to take a moment and guess what we're going to see. Number 1, 15, number 2, 15, number 3, 15, number 4, 15. This is really the same number. We are storing in these variables, but we are using a different representation that is going to be convenient depending on whatever it is we are doing. If it is more convenient to use binary, we're going to use binary. If it is more convenient to use hexadecimal, please do use hexadecimal. But the representation of this number in memory is really going to be the same. I really want you to take some time and let this sink in, because you're going to see these things a lot of times in your career as a software developer. So please do yourself a favor and make sure you really understand this. Okay, this is really all we set out to do in this lecture, trying to make sense of the binary numbers we have in memory and how it transform between them and different forms of data that is easily manipulable by humans. All data is represented by a bunch of grouped cells of zeros and ones. We have seen this. As the range of your data grows, so will be the number of digits you need to represent the data in memory. We have seen that the hexadecimal system makes it a little easier for humans to handle streams of data in ones and zeros. Octo has the same goal as hexadecimal, but it's almost no longer used in modern times. I just mentioned it here for completeness. We are going to stop here in this lecture. In the next one, we're going to look at integers in a little more detail. So go ahead and finish up here and meet me there. In this lecture, we're going to learn a little more about integers in C++. Integers are represented by int in C++. It's what you see on the left here, and they are used to store whole numbers, things like 1, 2, and 3. They typically occupy 4 bytes or more in memory, but in most times it's going to be 4 bytes. So, for example, if you have a variable called age and it is an integer, this is how it's most probably going to look in memory. It's going to take 4 bytes. And I really want to make it clear what the variable is. It is a named piece of memory that you use to store specific types of data. Okay, so here if we have a variable named age, it is a named piece of memory. Age is going to be the name of that piece of memory, and we can store data in that memory. It's going to look like this in memory, but the value is going to be stored in here in binary format. I really hope this makes sense. A variable is a named piece of memory that we can use to store different kinds of data in. Okay, now we're going to look at a few examples of how you can work with integers in your C++ program. You can define a few variables. Here we have one that is going to store the number of elephants we have. You can declare it like this and not put in a value. And if you do it like this, the compiler is just going to put in some garbage value that is really not meaningful for your program. So you see the warning we have here as a comment, the variable may contain random garbage value, and this is something you need to be aware of. Another way we can define integers in our C++ program is this statement here that declares a variable called line count. It's going to initialize to 0. If we use curly braces like this, it's going to initialize to 0 by default. We can also explicitly put in a value. We can do the same with cat count, and we can use these variables to do operations. For example, we can declare another variable, and it is going to store the number of domesticated animals, and we're going to add up the numbers for dogs and cats, and we're going to store the result of that in our variable that is called domesticated animals. This is something you can do. Another thing that can be problematic is trying to use variables that you haven't defined or declared in your program. That is going to give you a compiler error, and the compiler is basically going to say, I don't know what doesn't exist 1 here is, I don't know what this doesn't exist 2 is, it is not defined anywhere in the program. Another thing you can do is try and store a fractional number in a variable that you declared as an integer. And this is going to give you a warning because fractional numbers are usually bigger in size than integers. And this is going to lose some of your data. We don't really have enough tools to understand this now, but we are going to understand this a little later in the course. But this is something you can do. You can take a fractional number and store that in an integer variable. And we're going to do an example and see how this behaves with our compiler that is GCC 10. Okay, here we have mostly used curly braces to initialize our variables, but we can also use parentheses. And this is going to be usually referred to as functional variable initialization because we are using parentheses. And this is mostly going to do the same thing we saw in the last slide with curly braces. But when we come to the example here where we are storing a fractional number, this is going to silently chop off the data you have in a fractional number and turn that into an integer. And this is called implicit conversions. But if we go to the last example here where we are storing 2.9 into an integer, this is going to take this fractional number, chop off the decimal point, and only store 2 in this integer. And this might not be what you want, and it is going to happen silently. So this is a really bad way to do this. If you want to do something like this, it is preferable to use curly braces because you are either going to get a warning that this is going to lose you data, or you're going to get a compiler error, and the compiler is going to completely stop you from doing this. And again, if any of this doesn't make any sense, we're going to go in Visual Studio Code, play with us, and see how the compiler behaves with these things. We have another way we can initialize our variables in C++. We can use assignment, and we have done this a couple of times in the course, but this is something you can do, and we are going to play with us in Visual Studio Code in a minute, and you're going to see how it works. Okay, by now we have seen 3 ways we can initialize our integer variables. We can use braced initialization, which is basically using curly braces. We can use functional notation, which is using the parentheses, and we can use the assignment initialization, which is what we have here. Another thing I really want you to see is that it is possible to query for the size of your variable. Here we are trying to print the size in integer